Welcome. In this video, we are going to start learning the basics of cybersecurity and focus on network security technologies and protocols. A thorough knowledge of these aspects is necessary for a cyber analyst to effectively protect digital assets and, consequently, to have a successful career. Let's start with the basics. Network technologies. A network is fundamentally a group of devices linked together for communication. It functions as the cardiovascular system of a digital body. Types of these devices can range from a regular smartphone to complex servers or data centers. According to the type, networks are divided into local (LAN) and global (WAN). Local networks connect computers in small areas such as at home or office. Global networks connect computers over long distances, for example in different countries or on different continents. The largest global network is the Internet, which provides access to a variety of resources. Each type of network serves a different purpose, but they are all interconnected in the grand scheme of the digital universe. It's also important to understand the topology of networks as they shape the network communication plan. From star to mesh, each technology type shapes the way data moves. In addition, any cyber threat analyst needs to know how network equipment works, such as routers, switchers, and firewalls. Let's take a look at different network protocols, the rules and conventions that govern network communications. Basically, these are the languages that devices speak in order to understand each other. TCP/IP is a set of protocols that define the rules for exchanging data between computers within a network. It consists of 4 layers, where each of them is responsible for different aspects of data transfer and has its own protocols. The network interface layer, or link layer, responsible for physical connection and data transfer between devices in the same local area network. Internet layer provides the logical addressing and routing of data packets between different networks. Transport layer, responsible for reliable data transmission between devices. Application layer, provides services for user applications to interact with the network. UDP, User Datagram Protocol, is a simple transport layer protocol in the OSI network model. It transmits data quickly without guarantee of delivery or ordering. It is reliable for applications that may allow some data loss but require minimal latency. HTTP, HTTPS are the main protocols you interact with every day. Knowing how they work is essential to understanding how data is transmitted and protected on the Internet. HTTP is used to transfer data and interact with web pages. It transmits data in plain text format, which can be vulnerable to interception and modification. HTTPS is the same protocol, but with a security adds-on. That means over HTTP, information is transmitted in plain text, but it is encrypted over HTTPS. DNS, Domain Name System, is a protocol that works as a directory and distribution system for the Internet. It allows users to navigate the Internet using host names instead of numerical IP addresses. The DNS protocol is used in cyber attacks to direct traffic to malicious servers by hacking DNS queries or using DNS spoofing. Such attacks can lead to data interception, phishing, or even redirecting users to fake websites. Let's move on to discussing network security. It encompasses various policies, practices, and tools designed to protect the integrity, confidentiality, and availability of the network. There are several layers of security, where each of them plays an important role in creating a reliable protection mechanism. The physical level includes direct measures related to the physical restriction of access to resources or space. For example, access control to premises, use of barriers, locks, video surveillance systems, and other physical restrictions. The technical level is the use of technology. This includes the use of passwords, firewalls, encryption, intrusion detection system, and other technical tools. The administrative level includes policies, procedures, and rules. For example, timely changes and ensuring the correct storage and use of names, passwords, encryption keys, authority redistribution, etc. Next, let's analyze the network security guiding principles: confidentiality, integrity, and availability, known as the CIA triad. The confidentiality principle concerns the data privacy preservation. It implies that only authorized users have access to confidential information. To achieve this, encryption, access control, etc. are used. The integrity principle means that the data should remain untouched and not be altered without proper authorization. This is ensured through data integrity controls, such as hash functions. The availability principle means that the system and data should be available to users when they need them. This is achieved through backups, disaster recovery, and other measures to ensure business continuity. These principles are the basis for developing effective security strategies and help ensure the reliability of information systems. The first step of protecting is the ability to recognize cyber threats. They come in many forms, from malware and phishing to complex, persistent threats. Understanding their landscape and assessing risks is crucial. Effectively combating cyber threats requires proficiency in technology and the ability to utilize it. The cybersecurity analyst's arsenal includes firewalls and intrusion prevention systems (IPS). These are the gatekeepers of network security that monitor and control incoming and outgoing traffic based on the applied set of rules. There are also virtual private networks, known to us as VPNs. They create a secure tunnel for data transmission that serves to maintain the confidentiality and integrity of communication. And then there are EDR, Endpoint Detection and Response, and XDR, Extended Detection and Response Solutions. These are anti-malware tools that are constantly updated to recognize and neutralize threats. As technology evolves, so do the methods of protecting it. For example, encryption converts data into a secure format that protects it from unauthorized access during transmission and storage. It protects data at rest and in transit. Cloud security and hybrid solutions have become vital, allowing data to be protected outside an organization. With the development of cloud computing, this has become especially important. Another interesting method is the use of artificial intelligence and machine learning, which have revolutionized cybersecurity by offering new ways to detect threats and respond to them quickly and effectively. Let's also talk about monitoring and analyzing network traffic. Network traffic is a flow of data through your network, covering everything from emails to transactions with user data. Monitoring this traffic is like using a radar on a ship. It helps you navigate through the day-to-day business circumstances, as well as detect something out of the ordinary when it first appears on the horizon. To effectively monitor your network traffic, you need the right set of tools and techniques. The first step is to establish a baseline of normal network activity. When you know what the norm should be, it becomes possible to detect anomalies, that means deviations. These can be unusual traffic spikes, strange data patterns, or unrecognized protocols. Network traffic analysis is a process that involves the study, monitoring, and interpretation of data sent over computer network. There are different types of such analysis. For example, packet analysis helps you understand what kind of data is being transmitted, where from and where to. This allows you to detect anomalies that could be signals of security problems or network malfunctions. Network packets are small pieces of data that are transmitted over a computer network. Each packet contains part of the message, the sender and receiver addresses, and other metadata. Tools for analyzing network packets include, for example, Wireshark and TCP-dump. Wireshark is a graphical tool for analyzing packets that allow you to visualize and filter data packets. It provides a user-friendly interface for real-time viewing and packet analysis of your network traffic. Its capabilities allow you to detect problems such as network congestion, anomalies in communication between devices, attacks, and other anomalies. On the other hand, TCP-dump is a command-line tool for analyzing network traffic. The use of Berkeley Packet Filter (BPF) gives it more flexibility to automate the analysis and monitoring of a network. BPF allows you to develop your own scripts and filters for data processing, which makes TCP/DOM an even more powerful and customizable tool for working with the network traffic. Returning to the analysis of network traffic, a specialist can also perform trend analysis and forecasting. That means evaluating trends over time. Is the traffic volume increasing? Are new types of protocols emerging? Predictive analysis helps forecast future security incidents based on those trends. You should also integrate your own findings with threat intelligence. This way you can compare specific security activity with known threat patterns, which is a crucial step in proactive defense. Remember that it's your role in monitoring and analyzing network traffic that is the key. Every byte of data you analyze, every anomaly you detect, strengthens your organization's security.